So here in this forecast for day 4 we say that today is an anomaly. So this is the usual frequency distribution in MBAville, but today is an anomaly and the relative frequency of 1300 to 1500 calorie pizzas will be 5 times the normal distribution. So usually the relative frequency of 1300 to 1500 is 30 divided by the sum of all these, which is 30 divided by 500, which is 0.06, but today we say that it will be 5 times that, so it's 0.06 times 5, which is 0.3. And we also say that relative frequencies of all other ranges are same and equal to each other. So the relative frequencies of all other ranges are 1 minus 0.3, which is 0.7, and when they are same and equal to each other, there are six other ranges, and it's basically 0.7 divided by 6, which is 0.1. So the calculation for that will be again, you have 10 customers and the relative frequencies of this, and this is 0.11 each, and this one is 0.3. So when the calculations are done, we'll realize that the calorie requirement is close to 8,400. So let me just order that. And we start. This is day 4. I press on auto and everything gets distributed except for just one, so it was 8,200, and now you will see the solution which shows 8,200. So relative frequency of 1300 to 1500 is 0.06, but this is an anomaly case, so it's 0.06 times 5, which is 0.3. So relative frequency of all other calorie ranges is 0.11, and again it's the same formula that we saw earlier during the skewed distribution, that of midpoint times value of relative frequency times number of customers. So when this is done, it comes to 8,350 kcal. So let me just show you how the exercise works for this day. So in the exercise, we show all of the calorie ranges and their respective relative frequencies, and the BizFeed had taught a bit about cumulative distribution functions. So what happens here is that the student has to enter the respective cumulative distribution function, and as they keep entering it, the game will automatically plot a graph in this side, and the CDF graph is usually like this, and the graph gets automatically displayed, so the student knows that that's how the graph works for the cumulative distribution function. So without the exercise, I think students may find it a bit hard to do the actual forecast, but this exercise will come before the forecast, so hopefully this will help them a lot better in understanding core concepts. And this is, let's move to the game, got it. And the next day is about measures of location and locating points in a large data set. Now it's about percentile, quantile, and quartile, and all of these. The forecast is that today all of your store's customers will fall in the 94th to 100th percentile in terms of calorie intake. Assume that 94th to 100th percentile is same for your store and for MBAville. So 94th to 100th is basically the last 6 percentile, which is, so that's 0.06. MBAville has a total of 500 customers, so 0.06 times 500 is 30, and the last 30 here is here, which is in the 1300 to 1500 calorie range. So taking the midpoint of this is 1400, and when we have 10 customers for the day, the forecast basically tells us that all of the customers will be ordering 1400 calories. So we'll have to order 1400 times 10, which is 14,000 calories. Let me press try it out, and 14,000 calories, and I start. Customers come in and I press on auto and all of it gets distributed. So jobs have been done, and so since all customers fall in top 6 percentile, 500 times 0.06 is 30. So top 6 percentile refers to top 30 in MBAville. All top 30 fall in 1300 to 1500 calorie range. So our store's 10 customers will all be in 1300 to 1500 calorie range, and the midpoint of that is 1400 times 10, which is 14,000 kcal. So that's it for the game. And so for the exercise it will be like this. So all of these are the calorie intakes. They'll be allowed to, so this total calorie intake was basically calculated by taking the midpoint of the calorie range and multiplying it by the number of customers. So these can be dragged and dropped so that students can, if they want, arrange this in ascending order. And then they've been asked to rank the highest in terms of just highest calorie intake, and then they've been asked to find percentile. And these are the types of tutorials that will be there. The arrow will tell them to use %rank.inc in Excel to come up with the right percentile number, and then they can enter that here. And now we ask them to use %rank.exe function in Excel and ask them to enter the right percentile here. So this is just a simple example of a fill in the blanks in the game. So here it says that the percentile exercise shows that dash function on Excel includes values of both 0 and 100 percentiles. So this is the %rank.inc function here. So they just have to drag this and drop here. In our exercise with this function, the dataset had a total of 8 values, which was there in the table above, with the highest percentile value being 100, because in the .inc function the highest value is always 100. The second highest percentile was lower by, if you see here, the highest is 100 and the second highest is 85.7, so it was lower by 14.3. So they can just drag this 14.3 and put it here, and put it here. The difference was obtained by dividing 100 by 7. 100 by 7 is 14.3, which is 1 lower than the total values in the data set, which is 8 minus 1 is 7, so 1 lower. So this is one exercise, and the other exercise is that the percentile exercise shows that the dash function on Excel does not include values of 0 and 100. So this will be %rank.exe. In our exercise for this function, the dataset had a total of 8 values, again the same as last time, with the highest percentile value being, so here the highest, so this is %rank.exe, the highest percentile value is 88.8. So we drag 88.8 and put it here. The second highest percentile value was lower by 11.1. The difference was obtained by dividing 100 by 9, which is 1 higher than the total values in the data set. And that's it for this demo. Hopefully in 1.5 weeks the actual game will be ready, and it will be a lot nicer than the demo and a lot more user friendly and intuitive. Students will be able to build graphs and do a lot of visualization, and it'll also look like a game of sorts. So we are trying to replace textbooks using this gamified textbook. So hope you liked it. Thank you. Bye bye.